Hello, in this video, let's continue our series on machine learning using R. Today, I want to talk about how to implement multidimensional scaling, which is another dimensionality reduction technique. So multidimensional scaling, MDS, it visualizes similarities or dissimilarities between objects by placing them to low dimensional space, usually 3D, 2D or 3D, where distance reflect original relationships. So it's sort of distance preserving or order preserving projection. That's pretty nice technique. The input for MDS analysis, a pairwise dissimilarity matrix. You have to compute the dissimilarity matrix for interval data, ordinal data, or nominal data. Okay? And the output include the point coordinates and goodness of fit measures, such as the overall stress value. I will talk about later. And there are two main types of MDS. One is called the Metric MDS. The R packages for that are cmdscale and SMACOF for interval data. Okay. It preserves actual distances, assuming utility and structure. Another type is called a non-metric Ordinal MDS, and I recommend the R package isoMDS, preserves rank order only and more flexible for rank perceptual data. So I want to just share that I try to use SMACOF for ordinal data because they claim it can handle ordinal data, but it's just very sensitive and often fails. So I recommend you use isoMDS. Okay. Among outputs, you also see stress value measures with measures fit quality. Less than 0.5 is excellent, less than 0.1 is good, less than 0.2 is fair, greater than 0.2 is poor. Okay. And the CMD scale only output eigenvalues, and it indicate variance explained per dimension. Large positive means good fit. And also you can generate a Shepard diagram, shows monotonic regression observed versus fitted distances for ordinal MDS validation. Okay. All right, so let's load the library stats and SMOCOF, set a random seed, generate dissimilarity matrix for 10 objects. And also the last one is we assign 0 to the diagonals. And then using the base RMDS CMD scale function is very simple. Just feed the dissimilarity matrix to it. K equal to 2, that means we will project the data into a two-dimensional space. Eigenvalue equal to true. Okay. For using the SMACOF package, we use the function MDS and also feed it with the dissimilarity matrix. Now n dimension equal to 2 and type equal to interval. All right, so we can say compare the two. You can see there's a little bit difference in this what we call configuration plots, which are just showing the position of the rendered data set in the two-dimensional projected subspace. Okay. And we can print out the stress values. Of course, for the CMD scale function, it only has eigenvalues, but here both eigenvalues are large and positive, so it's good. For the SMACOF stress, it's only 0.218, so it's larger than 0.2, so it's a poor fit by that cutoff value. Okay. For ordinal MDS, I want to show you how to use the library MASS, and then you set a random seed. We can create a 12 objects, and then the maximum rank, so they're ordinal, so rank is 1 to 7, like the ratings. Okay, so we created the ordinal matrix, and then assign 0 to the diagonals, and we have to convert it to a distance object using the function s.dist. Okay. And now we can actually take a look. This is the ordinal part of the dissimilarity matrix. Okay. Then we can perform the ordinal MDS using isoMDS. The syntax is similar. So isoMDS ordinal underscore dis and the k equal to 2. We want a two-dimensional subspace. Maximum iteration equal to 2000. We want to assign a large maximum number of iteration just to guarantee R has enough steps, enough iteration to achieve convergence. Because for ordinal data, sometimes they take longer to converge. Okay, so let's do that. And it tells us it converged. And then we can do some visualization. So first, just print out the configuration. And then second, we can print out the Shepard plot. You can see a straight line, and then you have stepwise, line showing, the distances, the fitted distances against the original ordinal differences. So it's at the beginning, there's some discrepancy, and then eventually it catch up. And to get a really more accurate idea about the fitness, fit quality, we can print out the stress level. So here is the stress level is 24.27, also above 0.2. So it's a high, very high. So it's just very difficult to find a good fit for ordinal data. Okay, so you have to be careful with the MDS result you got here. Okay. All right. The main purpose of this video is to show you the ways you can actually carry out MDS analysis for interval and ordinal data using R. Okay. And again, these are not the only ways to do MDS. They may not be even the best way. Okay, but they are ways I have validated. Hopefully, it will be helpful for you to save you some time to explore. But if you do want to learn more about MDS, then you do want to explore other options. Thank you.